So, guys, let's talk for a moment about something a bit more complicated today, but I'll try my best to be both brief and precise. For beginners, this topic might seem somewhat difficult, but I sincerely hope you'll be able to understand it because we'll need all of this information later on. Alright, so what exactly is this about? This topic is about buffers and rendering. I'll keep it brief and just skim the surface without going into detail. Let me put it this way. All this information that I studied in depth and could, of course, stretch out into a long video and explain to you, you won't need it, at least not in the near future. I repeat and remind you that my goal is to gather all the information for you, and then you can decide for yourself which topics you need, which ones you want to study, and so on. Right now, we're talking about how materials work, and to understand this, we need to briefly go over this topic. The topic of buffers and rendering. So, to understand this, let's use a real life example. Like an artist who is drawing a picture, for example, he sees landscapes, distant mountains. People are walking, some object is in front, another object is behind, some are close, some are far away, and so on. In short, the distances to the objects vary. The artist also calculates perspective and determines where the light sources are. It could be the moon or the sun or maybe some lamps. He considers which side the light is coming from, how the light falls, what it falls on, whether it's close or far, whether the shadow is soft or hard. There's a lot of information there. So after the artist has already figured out in his head what should be there and how he will do it, he proceeds layer by layer, combining everything together. Unreal works in roughly the same way. It needs to know how to display this frame for us to show us everything. First of all, it needs to understand which objects are close to the camera and which are far away. Here is our camera. These objects are a cube, a sphere, and a cylinder. Our camera is closer than the wall behind it, so that's how Unreal works. If it doesn't understand, then small objects behind a large one would be shown in front of the large one, which isn't right. But if we move behind this wall, that is, look from this side, they disappear from view. So, logically, Unreal understands that this wall is closer than those objects. Actually, if we say that the objects are farther away, that's not entirely accurate because it's more correct to say pixels or even specific parts of objects to keep it simple and clear. For example, we have this cube right here and it can be half hidden, not completely. So instead of thinking about the whole object being far away, it's really about which parts or pixels are visible or hidden in the scene. That's why Unreal understands that part of this object is hidden and part needs to be shown. Okay, the first thing it determines is which part needs to be hidden and which part needs to be shown. All right, next, the G buffer is now coming into play in the rendering process. What I told you earlier about distance is actually called the Z buffer, which is the older name for it. Here, if I'm not mistaken, it's referred to as scene depth. Bright means far, dark means close. Okay. Next we have the G buffer. After Unreal figures out that some objects are close, some are far, and how it needs to display all of this, it starts to make rough drafts, sketches of what general objects there are. So the G buffer is like the geometry buffer, information about the geometry. It understands here are the objects, here is a metallic cube, here we have a rough sphere, and so on. Basically, the easiest way is if we switch to unlit mode. Here, this scene is without lighting, without shadows, just pure color. Objects and color, all of this information that it has gathered, it then carefully processes. It sees the objects and the pure, unaltered color. This particular metal has a certain series, this dark series, for example. So it takes this information and then passes it on for further processing in the light buffer, where the light falls. The light illuminates some objects, then shadows are cast, and so on. So in general, further processing includes ambient occlusion, normals, specular, and so on. There's a lot of information that it processes and combines. We just need to understand it piece by piece. It combines all this information, separates out what it needs to collect, merges it, and then shows us the final frame. And that's it. As for now, buffers, the second topic is rendering. Rendering. Simply put, it's a method or technique of drawing. For example, we have traditional drawing. We can draw with a pencil, we can paint with watercolors, we can use computer graphics, Photoshop, and so on. So, there are many ways. And in Angel, it does the same thing. In other words, it has its own way of rendering. In this case, I just remembered its name. Traditionally, it's called Deferred. But in general, it doesn't really matter what rendering method is used. As for volume, that's ray marching, volumetric clouds, volumetric fog, and so on. Everything volumetric. Of course, I could go into detail again. For example, to create this kind of lighting effect, it actually generates points in space, each one representing a certain density. There's a lot to say about lighting and other things, but I don't want to overload you. You don't need this information right now. Once you understand the information I'll convey to you during this course, then, if you need it, you can study and explore it in depth. When I tried to figure this out, I realized that in principle, even for game development, I never actually needed it. Well, honestly, I don't know what you would need it for. I don't really know exactly how. Unless, of course, you want to become a true expert in this particular field, everything I'm telling you here is more than enough. Enough to create the kinds of assets and games that I make myself. So, the rest is completely up to you and your own interests. All right, that's everything I wanted to cover regarding rendering and buffers for now. To sum up the main point.